So now let's talk about what antibodies are and how they work. So this is a figure showing a description or what an antibody kind of looks like. Antibodies have two arms, typically two arms. They're kind of Y-shaped in general in their structure. The arms are where you can bind antigens. And then here's the body of the antibody, okay? And they are proteins that are produced by plasma cells in response to some antigen. So humoral immunity can be either active or passive. So in an active immunity, we can either naturally acquire the infection. So think about when you get a cold. When you get a cold, your body has to produce antibodies to fight off the infection, and then you produce a memory for that. And so you'll never get that same cold. Problem is, colds mutate, and so you can always get a different type of cold. Artificially acquired active immunity would be where you're taking in a vaccine. So for those of you who have gotten your flu shots for this year, the flu shot is for the influenza virus that attacks the lungs and the respiratory system. In this case, the vaccine is going to activate our immune system and will produce antibodies against the virus. Now, vaccines typically are going to be produced by either using dead or attenuated pathogens. An attenuated pathogen is a pathogen that no longer can cause disease. Dead definitely can't cause a disease. In the case of viruses, because viruses are non-living, they would be considered inactivated, so they no longer can cause disease. We can also acquire humoral immunity through passive mechanisms. So naturally acquired passive immunity would be receiving antibodies from mom via the placenta or from breast milk. These antibodies will protect the infant, but they don't produce memory. So we don't have memory, so these antibodies will only last for 1 or 2 weeks. And then we can also artificially acquire antibodies. So through like injections of antibodies in a patient who maybe has who is immunocompromised. So they receive antibodies. Again, you're not going to acquire any memory, but you at least have those antibodies for a short period of time, maybe right before a surgery or something. Now, we can also use antibodies in treating certain diseases or in diagnosing certain diseases, and that's what monoclonal antibodies are used for. They're actually used to help in diagnosing specific types of cancer, as well as in treatment after exposure to rabies or hepatitis. So this is what an antibody looks like. You saw that one picture, and that was a computer-generated antibody. This is a diagram of an antibody. Antibodies always have a certain type of shape that's kind of Y-shaped in a sense. They have a region called a variable region, and then they have a region that's called a constant region. So you see the variable and the constant. They have 2 chains called heavy chains and 2 chains called light chains. It's the variable region that has the antigen binding portion on it. And so the constant region of any given antibody is going to stay the same, but the variable region will vary from one type of antibody to the next. There we go. So let's look at the 5 different types of antibodies before I talk about what you should be able to answer on the study guide. So there are 5 major immunoglobulin classes, and you can remember them by the word MAG, IgM, IgA, IgD, IgG, IgG, I'm sorry, and IgE, MAG. So IgM is what activates the complement system. IgA is typically found in our tears or in our mucus secretions. IgD is what helps to activate B cells. IgG is the antibody that crosses the placental barrier, and it is the most abundant antibody in our blood plasma. And then we have IgE, which is the antibody involved in allergic reactions and responses. So here's IgM. I told you that antibodies have specific structure, so they always had that Y shape. And so here we have an antibody that has 5 different branches off of it, but each of those branches has that same Y shape. And so you're going to have the constant and the variable region. The variable region is going to be where the antibody binds to the antigen. Here's IgA, and then here we have IgD, IgG, and IgE. So how do antibodies actually work? Antibodies don't kill pathogens. They can't kill anything. What they do is they inactivate the pathogen, either by activating the complement system. They will neutralize the pathogen by binding to the receptors, causing toxins that normally could cause damage to no longer be able to cause damage. They will cause agglutination, where you have something that is dissolved in blood plasma. It's now going to come out and become chunky, which would be like clumping of cells. Agglutination actually increases the ability of macrophages to phagocytize the material as well. And then precipitation, where we cross-link the antigens and antibodies, and that causes the antigen again to come out of the solution. And so here you can see those different mechanisms. When you activate the complement system can increase phagocytosis, activates chemotaxis, which again stimulates phagocytosis because we are releasing chemicals that enhance your macrophages and neutrophils to move to that site. And it can lead to cell lysis through that MAC attack. Here we have precipitation of antigens. Here we have agglutination of cells. And here we have neutralization. So now you should be able to answer the following questions. What is artificial active immunity? What is natural active immunity? What is artificial passive immunity? What is natural passive immunity? How do B cells become activated? And what are the 5 major different immunoglobulins? I'm going to keep going. This is a 9-minute video, but I think, hold on a second, let me look. Actually, I'm going to stop here. This will be a shorter video, and then we'll pick up with the T lymphocytes. Have a great day, and I will see you soon, or talk to you soon. Bye.